Hi guys. So we'll be talking about Leetcode question 120. It's the problem is named triangle. So given this like triangle format, return the minimum path sum from top to bottom, right? So we have in this case like you can traverse only from top to bottom, right? So you can go 2 3 6 4 2 3 5 1. So in this case like there are various ways to traverse. You can go like this. 2361, 2351, 2358, 235, no, 2451, 2458, etc., right? And then the minimum path would be 2351, right? And if you add these values, you get 11. So we have a top-down approach. I'm going to solve it by the top-down approach. If I have time, I will use the bottom-up approach, but we'll see if I have time for that. So just to reiterate, what is top-down approach? It basically uses recursion, and then but recursion can like overflow. So that's why we use memoization. So this is like the technique. Bottom-up doesn't use recursion, so that's why it's faster. Recursion can get very expensive depending on the problem. So now we hear this is a recurrence relation dictionary, basically stores like pre-computed values. So here triangle of ij would be the value at index ij, right? And then here minimum would be, you have two choices, right, in the path. So if you see here, you have two, you can either go here or here, right? So C1 would be minimum path of I plus 1j, and then C2 would be minimum path of I plus 1j plus 1, right? So here 0, 0, you either have of choosing going 1, 0 or then 1, 1, like in terms of like the index. That's why I wrote it down, just for the sake of clarity. Please pause and try to understand it if you don't get it. So this, for those of you who don't know, I think Fibonacci is really helpful here in this context. Fibonacci is basically you add the values, right? According to, you start from like F1 and then you add F2 to get F3. But to get F4, you get you have that F3 plus F2, and F5 would be F4 plus F3, right? So here Fn would be Fn minus 1 plus Fn minus 2. So why am I talking about this? It's because you see here F5, right? So we start from the bottom, right? F1, and then we slowly calculate up. But as you go up, you see that like F3 has already been calculated and F4 has already been calculated. So in order to calculate F5, you just need to recall what F3 and F4 is. So you don't need to like actually go deep down into the recursion tree. So you can just store the F3 and F4 values, right? So that's really helpful. So that's where like the dictionary comes in, or hash map for Java people. So now here is the tree again. So this is the recursion. So triangle ij, right? This would be 0, 0. If we start at like 0, 0, and then we do the branching of the recursion tree, right? So we do 1, 0, and then 1, 1. For here 3 would be 2, 0, 2, 1, right? So that's why given ij, the indexes we're interested in are I plus 1 and then j, I plus 1 and j plus 1. So now I just want to reiterate like the definition of the min path, MP in this case. I abbreviate it. So here we're trying to find the minimum path up until point ij, right? I think that makes sense. So here, like you see, I rewrote the tree in terms of like recursion. So you see MP right here, and then MP of 1, 0. So now when we do MP of 2, 1, let me just think. Yeah, so when we do of MP of 2, 1, MP of 1, 0, then we have the value of I1, value at 1 comma 0 plus the MP, the minimum of this, or the minimum of these two basically. So now we know once we recall min path, or like the dictionary in this case, it will regurgitate, it would find the minimum path up until this point, correct? And then yeah, and then this would like store the minimum path up until, meaning like if it comes from the bottom. So now just to reiterate, I thought it'd be really helpful to see where the actual repetition occurs. Like, why do we even need to use the dictionary? So yeah, so if you see here, right, so MP of 0, 0, this would be the triangle value at 0, 0, and then you would have the minimum path of choosing this value or this value, correct? So if you expand this, right, MP of 1, 0, it would be the triangle value at 1, 0, and then minimum of 2, 0, and then MP of 2, 1, correct? So now, MP of 2, 1, we can see that, like, assuming like we truncated the tree, since this is a branch, this would like just be the value itself, right? So in our case, it would be just 5, right? Let's say we just truncated the tree here. So now this value will be stored in the dictionary. But here, if the recursion is not done, right? So we have MP of 1, 1, and then we basically start here, and then we have the triangle value 1, 1, and then minimum of MP of 2, 1, and then MP of 2, 2. Oh, but where have we seen this before? We have seen it, right? MP of 1, 2, 1 is 5. So imagine, like, I truncated the tree for the sake of illustration, but like let's say this tree was ginormous, right? So like this will have a lot of values in the middle, but we want to like only see we don't want to like keep doing the computations like twice. So if the recursion, like computers are stupid, like if you ask them to do it, they'll just do it without thinking. So like unless you memorize it, it'll just keep doing it. So and then if it will go down here, and then like it would do the recursion down here, and that would be very expensive, but you only need to do it once. But if you don't do it, like if you go down here and then recurse down here, you would have to repeat this all over again if you don't have the dictionary. So that's where the memoization is really helpful. So now you can clearly see like MP of 2, 1 would be just basically, it'll be pre-computed. So you just need to regurgitate this, and then this unfortunately was not pre-computed, so you would have to go down this recursion path if there are more values. But I did truncate it for the sake of simplicity. So now just to talk about the code, so this is the given problem statement. So rows would be like the length of the triangle, right? So I think in our case, there would be, so there's row 1, 2, and then 3, and then 4, right? So the rows would be length of the triangle, so 4 rows, right? And then dictionary would be the number, the actual memoization table that we have, and then min path would be here, and then ij would be in dictionary, correct? And then we would return dic of ij, correct? This is basically indicating that like if the value ij is pre-computed, then we just return whatever we pre-computed before. So in our case, it would be like an example would be 2, 1. So that's where it happens. And then this is like if I is equal to rows minus 1, right? So if you see here, like the indices, right, are 3. Because in CS you start with 0, so that's why like this index would be 3, but the actual rows numbers, if you see, are 4. So once the I hits I is equal to 4 minus 1, which is 3, then we know we're at the leaf level, correct? So now we just return the triangle value, and this is just a recurrence relation that I've been talking about, and then this is, you just store this value within this dictionary and just return the value. And then here, basically, you return the minimum path, or the same function. The reason why I did this function within the function is because I wanted to access the dictionary. It kind of acts as like a mini global variable, so I don't have to keep passing it in. It's all accessible within this function. And that's like the beauty of Python, I think. Here, so you have MP of 0, 0, and then here, so you have MP of 0, 0, and then like it would just traverse downwards, and it's guaranteed to like traverse every possible path. And then once it recurses back up, this would store the minimum path. That's it. Thank you very much.